Our agenda for today. In the next 15 minutes, I will present some ideas about the importance of an inclusive data integration capability as the first and most critical step for any digital transformation journey. Then, Christoph Merlin, Senior Solution Architect at Qlik, will showcase how real-time data from SAP can be delivered to Azure with the Qlik Data Integration platform. Finally, Dimitris Koutsanastasis, Senior Data and AI Specialist at Microsoft, will present Microsoft Azure Synapse. Of course, there will be a Q&A session for about 10 minutes at the end. The questions raised will be answered by the presenters, and in case of any unanswered questions, they will be replied offline and shared to the audience via email. Before I go on, let me briefly introduce WITSIDE for those who don't happen to know us. We are an augmented analytics provider, helping our clients enhance human judgment, which eventually leads to effective decisions. This enhancement is achieved through best-in-class analytics, applications, and deployments. We serve a clientele of more than 350 clients across 10 countries in almost every single sector and size, from enterprise level to SMEs. Our main focus areas span across 4 pillars. Data management, any activity related to the design and implementation of data architecture, ETL/ELT, data warehouses or data lakes, and data migration activities. This pillar also includes any activity concerning data preparation for machine learning or any other advanced analytics applications. Second, data visualization. This has to do with building the appropriate data visualization formats according to what our clients need. Here we're talking about dashboards, reports, and alerts based on business rules, all belonging to the traditional business intelligence spectrum. Third one, advanced analytics. This is a relatively new pillar for us, grown during the last couple of years. We solve complex business problems with machine learning, time series analysis, optimization, statistics, and other techniques. Those business problems are mainly related to consumer insights, such as demand forecasting, trade promo analysis and optimization, customer profiling, etc., and supply chain insights, such as inventory optimization, capacity planning, predictive maintenance, and so on and so forth. Finally, our data analytics consulting practice, where we help clients answer questions such as what is the best data architecture for us, or how could we build an effective data science team? Which applications should we use for real-time data ingestion? How could we upskill our entire personnel in terms of data manipulation? Or we want to digitize our business model. Where should we start from? Such questions are among the ones we help our clients with. Now, let's get back to the subject of this presentation. Please take a closer look at those pictures. What do they tell you? Let's very quickly go through them. What we see is a chart, a couple of dashboards, a digital twin of a production machine, a financial statement report, a production downtime alert in a mobile device, a pallet handling robot, and a remote surgery installation. What do all those pictures share in common? If we think about it, this will make a more clear picture. So, organizations have been traditionally exploiting batch data processing. Some of them in an optimal way, some of them in a not optimal way. A dashboard is a classic example refreshed on a daily, weekly, or monthly basis. A P&L statement is usually the outcome of a monthly data processing process. On the other hand, one could realize that real-time data processing is an absolute prerequisite for pallet handling or remote robotic surgery. So in order for an organization to be capable of deploying such solutions, it needs to have a data integration capability that covers both batch and real-time processing. The building of such a capability is the absolute prerequisite, the first step of any other digital transformation initiative. According to Forrester, insights will spoil if enterprises don't use them in a timely fashion. Competitors that have a fresher data and the analysis to use it effectively will have an advantage over them. Timeliness is a term often used in a twofold meaning. Essentially, it is the time between when data is expected and when it is readily available for use. However, it often also implies the notion of currency. It means how up-to-date our data is. So timeless and currency are becoming the most important data quality factors today. In that sense, firms spend millions of data and analytics seeking interesting ways to slice and dice historical information about the business. None of it matters if they can't timely act on this information to move the business towards its goal. So insights derived from data analytics have expiration dates, and like crops in the field, they need to be harvested before they rot. So the message here is clearly the timeliness and currency of information. Otherwise, we lose the value. Okay? As we see the chart, real-time insights are used to automate processes. Firms derive these insights from the high-speed, high-volume torrents of data that are generated from sources like financial markets, manufacturing, equipment, ad buying services, web traffic, etc. Each event within these data streams presents an opportunity to act, but these actions must be executed far faster than humans can respond. Making use of insights in real time requires building intelligent applications and processes that not only reveal the insights, but act on them immediately. Indicative examples are contextual customer recommendations, preventive maintenance, compliance and fraud monitoring, and mitigation, and so on and so forth. This is in the low perishability, short time to action spectrum. Okay. Second, operational insights for immediate decisions. Here, line managers and employees use operational insights to make immediate adjustments to business processes. The data driving those insights often arrives with the same lightning speed as the data for real-time insights, but the decisions that firms must take can still be made at human speed. As examples of this, we could mention employee shift scheduling, delivery truck routing, and marketing campaigns. Low to medium perishability, as you see, short to medium time to action. Third category, performance insights for near-term monitoring and course-correcting decisions. Performance insights provide key performance indicators for the business. They help measure how well the business is executing against its goals and are typically used to fine-tune operational execution. Those insights are often delivered in the form of batch reports and dashboards, but the pressing need to accelerate business decisions is increasing the cadence. Performance insights, especially when data is available from streaming systems, can now be gleaned within hours rather than weeks. Okay, so all this information has a medium to high perishability and a medium to long time to action. Finally, strategic insights provide enterprise leaders with intelligence they can use to make long-term decisions. Use cases can be mentioned as new product development, the decision of entering new markets, decision over organizational changes, and so on and so forth. Okay, high perishability, long time to action. A similar finding was published by Nucleus Research in a study called the Half-Life of Data. In their study, the team argued that data has a half-life. The value of data diminishes based on the cadence of decisions. Decision tempos are tactical, here driving process changes in almost real time, operational, taking days or weeks to implement, or strategic, which has a more longer, let's say, spectrum. The main conclusions of the study are that the average half-life of data for tactical decisions is 30 minutes or less. For operational decisions, it can reach up to 8 hours, and for strategic decisions, it can stretch to an average of 56 hours. Okay, so the outcome of this research is that there is no just one type of data. Even companies with strategic or operational focus necessarily need to devote a portion of their collective time to tactical concerns. Hence, a strategy based around the concept of data half-life can help managers redefine their data integration strategies. In other words, your data integration strategy should take into account all three forms of decision tempos, tactical, operational, and strategic, and treat them accordingly in order to maximize their value. Now, let's assume you are investigating your options regarding your data integration landscape in order to be able to process any kind of data, as we said before. You have completed the draft vendor evaluation process, and you have a draft effort, timeline, and cost estimates. These are good and common preparation steps for any data integration project. What would you need to do next in order to get the ball rolling, actually rolling? The next step would be to convince the senior management, be it sponsors, board of directors, C-suite, etc., about the need for investment and how you are going to do that. By translating this need into tangible value. A very useful way to do this would be to use this assessment formula as shown in the slide. According to this formula, the value of an investment is the sum of money saved, money made, risk reduced, and opportunities captured, minus the total sum of the investment. By quantifying the expected value and comparing it with the current state, looks like an effective way to communicate with the C-level and get into a yes for any investment. You could quantify, for instance, the decrease of downtime risk due to the deployment of a predictive maintenance solution by looking at the average downtimes per machine, production losses, sunk labor costs, and the potential SLA breaches. One could calculate the expected gains from a 20% decrease of critical incidents in the production process. This is something that the production director or the C-level would understand and they would buy. Similarly, doing the math for all use cases that will be enabled by the new data integration platform would reveal the value and potentially raise the odds of getting into a yes in terms of investment approval. So, in conclusion, if somebody asked me what would be the main messages of this presentation, I could only pick two. First one, label your data in terms of perishability. The crucial part is to capture as many of your data sources as possible, be it ERP, social media, budgets, planning, production data, sellout, inventory, transportation, last mile, trade promos, and so on and so forth. Okay? Second, use the assessment formula and calculate the value of every single use case of any type. Effort savings due to automations, risk mitigation, process automation, predictive maintenance, reporting, dashboards, etc. Okay? Only if you do this math, you will get your projects approved, because this is the only way for the C-level to understand what you're doing. So I hope you have found this short presentation useful. It's about time to get into a more practical stuff on how a successful data integration project with real-time ingestion capabilities with SAP as the main data source would look like. So I'm passing on to Christoph Merlin, Senior Solution Architect at Qlik, who's going to talk about delivering real-time SAP data to Azure and Synapse. Thank you for your attention. Enjoy the rest of the event. Christoph, the stage is all yours.
Thank you. Let me quickly share my screen. So my topic for today is how to unlock your SAP data and deliver the data into the Azure platform. So we can deliver the data into Synapse, into Databricks, whatever you prefer. We have connectors to deliver the data into the Azure cloud platform. So my name is Christoph Merlin. As Konstantinos mentioned before, I'm working with in the partner engineering group of Qlik, and I have long experience with Qlik, former at Unity, did a lot of projects with the QDI platform, and I will guide you in the next 25 to 30 minutes through my presentation. So why are we preferred partner of Microsoft? We, as you can see on the slide, we we are the technology partner of the year for Microsoft in 2019. We did lots of big projects moving the data into the Azure cloud platform. So if it's Synapse, if it's an SQL database, really it doesn't matter. So we have the connectors to move the data into the Azure platform. So we help Microsoft also to increase revenue on their cloud strategy. We have worldwide lots of references how to unlock the data and how to move the data into the Azure platform. You can start in US with Walmart and go to Germany, ABB, Lufthansa. So we did lots of projects worldwide, and we are really a preferred partner of Microsoft. Also, what you can see here, if you see the Gartner report 29 and 2020 looks quite similar. Data integration or making data available in a cloud platform, that's one of the big use cases we see everywhere. All customer needs working with real-time data, working, let's say, with renewed platforms to really use their data in the right and a correct way. And what you can see here, we are the leader in moving the data from different, let's say, on-premise systems, could be also cloud systems, in a one common cloud platform. Microsoft Azure is one example of it. So what are the key requirements when you move data, let's say, to the Azure platform? On the one side, CDC streaming is really, really important. You see it also later in more detail. So we have different ways connectors to access the data, specific, let's say, SAP data, mainframe data sets, and move the data into a cloud platform. And then if let's say the batch load is finished, then we switch over into CDC. CDC stands for Change Data Capture, and we usually use the transactional logs. Also, we can use triggers. We can use some other ways to get the change data, CC delta, and move that delta into the cloud platform. And that's really a big advantage. So we call it a near real-time or real-time replication tool. And then if the data are, let's say, in the cloud platform, then usually we move the data into, we call it a landing area. And then the second part of the QDI platform came into the game, into place. We call this Qlik Compose, data warehouse automation and data lake creation. Then we can able to prepare, aggregate the data. In the end, call it a 360-degree view on your data, and then you can start working with the data using Power BI, using Qlik Sense to analyze, consume the data in the right way. So why do organizations benefit from a new modern analytics platform? I call it a data platform. Usually when you access different source systems like, let's say, SAP specific and also mainframe, we reduce the cost on the mainframe side. If you are not moving any load on your mainframe side, we call it reducing the MIPS. That means you are saving money, not using the mainframe side at all. It's the same, almost the same sometimes with SAP. So if you move both different data into a cloud platform, and then you can start working using the data without any additional cost, you are saving quite a lot of money using a new modern data platform. Also, what we are also seeing, working with real-time data, that's really important that you can do the right conclusions. Maybe you can react on something quicker than before, and that also helps you also reducing your costs and as well making your customers, your users, your consumers happy working with the correct data. That is the benefit having a modern data analytics platform. So how we are doing it? So Qlik QDI, Qlik Data Integration, that's a platform with different products behind. One is, we are talking today about it, it's we call it Qlik Replicate, to move the data from A to B. The second one is Qlik Compose, to aggregate the data, prepare the data, and make it analytics ready. That is what we are doing with the Qlik Data Integration platform. So what you can see here on the left side, you see we have different we have connectors to access that data, unload let's say the data, deliver it into the Azure platform. It could be Synapse, it could be Azure SQL database, it could be whatever it is. We have the connectors to take the data from different source systems and deliver it into the Azure platform. And in the end, the consumers coming on the right side and consuming the data in a really easy way. I'm going a little bit more in detail how it works. That's specific now here with how we do it with SAP data and move it into Azure. So as I said, we have the real-time ingestion. That is, we have the connectors to connect to the SAP platform applications. We have different ways doing it. We have, let's say, a standard connector. We have using the extractors, and we have a log-based solution. So it's different kind of ways we can connect to SAP. Then we move the data into, we call it the data lake. And that's what we are doing. We are taking the structure of the source system, defining a business model, working with a business model, can combine different business model together, and in the end we create a new structure for a data warehouse. And then on the right side, the users can consume the data quite easily. So a little bit more in detail here, specific one on Azure Synapse. Again, here on the left side, different methods to connect to SAP and as well as other data sources. And then we define a job, how to unlock or how to load data from the different source systems into a landing zone on Azure. And then, first of all, we do an initial load. We call it just select star on a database and move the data. If that is finished, then we make automatically a switch into, we call it change data capture, CDC mode, and also move the delta into the Azure platform. Also, what we recognize in the whole process, we call it the structure changes inside the source system. If you add a column to a database, we recognize it and then also deliver it into the target side. And then that was Qlik Replicate. And then it's Qlik Compose comes into the game, where we start working with a model. And as I said before, if you have different source systems, then we can combine models together by using, let's say, a table, some columns, some items, whatever, and defining in the end a 360-degree view on your data. And then we define the structure of the new data warehouse. And we also define automatically the ETL set, which is necessary to load the data into the data warehouse. In the end, we create a data mart, data vault, sorry, and then the consumer can use in the end the data. And that whole process is fully automated. So on the one side with Replicate, we moving automatically the data also in CDC mode from A to B. Then we generate a new structure, and also that's also a process which runs automatically. And the consumer in the end are working all the time with the news and the accurate data. That is how we offer with Qlik QDI platform. Different view on that. Again, it's more and more detailed. You see here connectivity to different source system. Batch load, CDC load, we move it into a storage on the Azure side, and then we prepare the data, create a data vault in the end, and finally different data marts, and the consumer can use the data. A little more in detail what we are doing with Replicate. Again, connectivity is pretty clear. And also how to move the data into the target side. So we are in memory replication. So we are not storing any data on the Replicate server. We're just taking the data, read the data, and deliver it automatically into the target side. And also we can also prepare the data on that way as well. So we can do filter, just taking also the relevant data, which is important for you. We can do also some transformations to get, let's say, the date time. So we have in the end on the target side the accurate date time for all different sources as a one common date time column that can be used by Compose, and in the end can be used by the consumer in the end. Also, the cache store, if for some process are failing, we store also where we are in the process. If the connection is established, then we can take over automatically. And that is what we do support with Qlik Replicate out of the box. So target schema creation, data type mapping is quite important, that we deliver the data in the right data type on the target side. DDL change propagation, that means we can recognize DDL and DML changes out of the box. Filtering, transformation in memory, I already talked about that. High-level overview, we have seen it in a different way. I mentioned before is we have different methods to connect to SAP. We see here transaction logs. And in SAP, we can use Trigger, we can use extractors also, we can use the transaction logs to measure the delta of SAP. So we have different methods to connect to SAP, but that is usually the way. The source tables, moving all the data from A to B, and then if the process is finished, then we switch over to the transaction logs, or we can use Trigger to measure the changes, especially when you connect to SAP. But we have different ways to connect to SAP. So just on high-level overview, what we are doing, let's say with Compose, with Replicate, we already move the data in a landing zone, and then we start working with a model, defining some mappings, put some additional attributes to that model, can combine that model, then we create the EDW, the Enterprise Data Warehouse structure, generate automatically the ETLs, and then in the end we create the data map, then it can be used by consumers in the end. That is a quick overview of Compose for data warehouse. We have the same Compose for data lakes. Then also we also move the data again into a data lake, also in a landing area, where we also prepare, aggregate the data, make it analytics ready. Also we also using the structure of the source system, enrich the data with metadata, enrich it with additional metadata, and finally store the data into an operational data store. And then the consumer on the right side can analyze and work with the data. And also we have lots of different options inside that. We have a metadata management with cataloging, lineage, etc. Everything is part of the product. And also that process, Compose for data lakes and Compose for data warehouse, is a fully automated process. How we work with Databricks. I talked quite a lot about Synapse before. Also, we have connectivity to Databricks to move the data into Databricks, and then we also doing the same with Compose for data lakes, enrich the data, add some new metadata, using the structure of the source systems, just make it analytics ready, and then we can create an operation data store or an historical data sets. So that's what we can do out of the box, also with connectivity to Databricks. So we have lots of different references. You have seen also in the beginning on one slide about talking about references, specific unlocking SAP data. We have Centricard, we have Devon, T-Mobile, Clean Water. So we have lots of different references. For all the reference we have, for them it was quite important working with SAP data, getting, let's say, the freedom also working with SAP data. That means we need to unlock first different applications, could be an ECC, could be whatever is in the end, taking the data out of SAP. Then when Compose comes into the place, working with the data, preparing the data, make the analytics ready, and in the end, the consumer can work with the data. The freedom, what I mean is you can connect to the Azure platform wherever you are in the world. You don't need any let's say client to connect to SAP. You are really the freedom to work with the data. And also we do understand SAP data. We acquired a couple of years ago a company. It's called Gold Client. We integrated that product into Replicate and Compose to understand pool, cluster table, and index table. And it really doesn't matter if it's an application or it's a HANA. We do understand SAP data, and that is really, really important. Yeah, you see again the use cases more in detail. Maybe I can take just one of them. For them, let's take T-Mobile or Ferguson as an example. Accessing, let's say, the different applications of SAP data, also combining the data quite easily coming from a different source. If it's Oracle, SQL Server, or mainframe, really, it doesn't matter. So we move the data, all the different kinds of data, into the landing zone, and then with Compose, we can start working with the data, combine the data, and finally, as I said before, you get this 360-degree view on your data, and you can start working with the data quite easily. So again, what I said before, unleash SAP data and do more. Again, you got the freedom to work wherever you're on the world. You can work with SAP data. You don't need any client to log into your SAP application. We do understand pool, cluster table, and of course, we also do the real-time ingestion into the Azure platform. That is why we are Qlik QDI, Qlik Data Integration is a good platform to move the data into the Azure platform. Now I'm finished with my presentation, so I will show you a quick video, a demo, what we do, how we are doing it, and give me 1 second. Now you see it. With also now, hopefully we say.
Yes, and we can hear.
All good now.
Hello, my name is Dave Fergs, and today we're going to talk about how to unlock your SAP data with Qlik Data Integration tools working with Microsoft Azure Synapse. So let's take a quick look at the architecture for a configuration using Qlik Data Integration tools with Azure Synapse. So we're going to start here on the left with our SAP system. We're going to connect up to that, and there's a number of ways we're going to connect to that. Could be anything from direct tables, cluster tables, pool tables, extractors, or any number of entities from SAP. We're going to load that information using Qlik Replicate into Azure Synapse. We're then going to keep that data synchronized with real-time change data capture. We're then going to use Qlik Compose to turn that raw information into analytics-ready data warehouses and data marts. And at the end of it, we're then going to be able to analyze that information using Power BI. Let's go ahead and take a look now for a second at some of the components and functionality available inside of Qlik Replicate. In this diagram, we're going to see that we're connecting up to that SAP system as referenced on the left side. We're going to do a batch load, start the change data capture. It's going to allow us to replicate the target schema, do some heterogeneous data type mapping, propagate the DDL, allow us to apply filters like SPROS equals E for English tables and values, do any inline transformation, and load that into Azure Synapse Analytics. So let's go ahead inside of Attunity Replicate here, go ahead and start the process of taking our data from SAP and loading it into Synapse Analytics. So to do that, we're going to go ahead and start by choosing tables. Now I'm going to go ahead and choose some order to cash information from the sales and distribution module. I see a list of tables that I'm interested in. I'm going to go ahead and add them all, and I will hit OK. And that's all it takes to set up the initial bulk load. Now, if I take a look at my task settings, I can see that I'm actually going to go ahead, when this process starts, I'm going to go ahead and apply change processing. So as new SAP transactions come in, they will be automatically sent over to Synapse for processing. In order to start the process of the change data capture and replication, all I have to do is essentially hit go. At this point, the job will start running. The information will start being pulled from SAP and being written into Azure Synapse. So while our tables are finishing loading here, we got one relatively large one we're still waiting on. Let's go ahead and start monitoring the process of change data capture. So while the system is now monitoring new transactions, I'm going to go into my SAP GUI and make a change. I'm looking at an order and somebody's entered it wrong. I thought they tried to order 2 iPhones, and yet the order went down as 2 million iPhones. Well, that's kind of wrong. And so what we're going to do is go ahead and update this transaction here to 2. And when we go ahead and update this transaction, I'll go ahead and hit save. It will now register this transaction. I can see now that what's happened here is that it's went from 2 million to 2, and I will start to actually see the fact that the transactions are now being written in real time from my SAP system into Azure. So if I go look at the amount of updates, I can see that it updated the transactions, and we'll go take a look at this in just a second in Power BI. But it's that simple. I changed an order, it cascaded through the SAP system, and was immediately written into Azure Synapse. Now that we've seen the process of the data being replicated with change data capture into Azure Synapse, it's now time to transform those cryptic SAP models into something usable by analysts. And to do that, we're going to use Qlik Compose. Qlik Compose is going to automate the data processing and the transformation from shorthand German into actual usable functional names. It's also going to manage the data warehousing component of it. Things like surrogates, things like slowly changing dimensions, type 1, type 2. It's also going to be able to create analytic-ready data marts for Power BI. So this entire process of now taking that raw data, transforming it into something ready for analytics, is what Qlik Compose is going to bring to the table. So let's go ahead and take a look at this now. We're going to go ahead and open Compose for Data Warehouses by Qlik here. And this is the process of taking that raw to ready information. And so we're going to see the transformation process starting from left to right. We're going to see the fact that we're picking up the output from that database, the SAP DW demo. We are going to write that out into a data transformation model, which we can take a look at here. So if we validate, it looks good. If we take a look at the display for it, we're going to be able to see how we're going and approaching some of that information from taking it from the different billing documents, sales documents, and region, industry, country. Some of that information that you would see originally in German is now been transformed into a reasonable and understandable language. And taking these processes, we're going to then actually go through this process of creating the data warehouse. So if we take a look at that data warehouse, these are the outputs, these are the tables we're going to create. These are the 711 instructions we're going to go ahead and run to actually populate this, to automate the process of creation. And then once we've gone through the process of creating the data warehouse, we're going to go an additional step of creating an analytics data mart. So this data mart is what a Power BI user would then use. It's already got the keys set up. It's already got the cardinality set up. So it's very easy to snap into this and start doing analytics. So let's go ahead and take a look here at Power BI on top of our output from Compose. If we go ahead and take a look at our data model, what we're going to be able to see here is that we've connected up to that output, being able to leverage the various tables that were created in that data mart, whether it's the fact sales information, material information, customer information, sales org information, or industry information. And I noticed when I created this, they automatically snapped up and created the joins for me because we went through the process of managing that creation inside of Compose automatically. Now, if we go take a look at this, and we go take a look at our dashboard, we can see here that we indeed are able to look at this information. Now, this dashboard was run, and I actually get an indication that there's I need to go look over here, and I can go ahead to the process and now refresh my information. So because we've run this Compose job to pick up the change data capture and push it and cascade it through the system, we're going to be able to now refresh that information very quickly inside of Power BI. So when I hit the refresh, it will go now query that data mart, and it will pick up those new changes that we've gotten. The fact that we made that change from 2 million orders of that iPhone to 2 orders. And we'll see that reflect here in just a second. And there we go. Just with that quick change, we now see that we're sitting at 16.97 billion, down from 18. So in fact, that change had been cascaded through the system. So again, what we've seen here is going from raw to ready to analytics with Qlik Data Integration tools, Qlik Replicate, Qlik Compose, and Power BI in the end to actually start consuming the information. So this whole suite together is a very powerful way for customers to get their data out of SAP and start best practices analytics with the combination of Qlik and Microsoft Azure Synapse Analytics. Thank you very much.
So my conclusion of my presentation is, so with Qlik Data Integration, you have the possibilities to have the full data pipeline. That means accessing your data, prepare the data, and finally use the data in the end. That's what we can offer with Qlik QDI, with the Qlik QDI platform. Thank you very much.
Thank you very much, Christoph. So our next presenter, Dimitris Koutsanastasis. Hi, Dimitris. He's going to talk about Azure Synapse Analytics. So the stage is all yours, Dimitris.
Hi, everybody. Let me quickly share the screen and get started. Yeah, I need to click the share. All right, okay. You should be able to see my screen, right?
Yes.
All right, awesome. Let's get started then. So, just as a continuation, let's say, to what Christoph was showing and what Konstantinos earlier was speaking about, I'd like to double click on what happens after we get hold of the data and see a bit more about what this Synapse Analytics is all about and what it can offer, let's say, what it brings to the table. Now, you'll see later on that there are a lot of things that are included, let's say, with Synapse. We will be able, within these 20 minutes, to just take a highlight, a quick, let's say, overview, let's say, of what's in there. And I've managed to, hopefully, I'll manage to squeeze in a bit of a demo just to see it in action, let's say, and what we can do there. So, in order to get started, I'd like to sort of set up things, let's say, in a clear manner and see where exactly we land in terms of a classic reporting pipeline. Now, within this pipeline, you get the ingestion point that we very nicely see, let's say, from QIP, that it helps us do all these tough tasks like doing the CDC and getting the information from systems like SAP. And then you land them, let's say, on a repository, and you need to do some sort of analysis, some sort of transformations, and serve them to the presentation layer, which might be whatever. So within this sort of storing and prepping the data and then serving the data, we have this, what we call Synapse Analytics. And as you can see, it's more like a suite of services. It's not one specific service. And it can encompass various kind of traits and characteristics. Now, just to dive a bit further into it, the one thing that stands out, let's say, as a main compelling argument, let's say, in favor of Synapse is the fact that it blends together two major worlds. The first one is the big data world, and the other one is the relational world, the reporting world. And this is where it's sort of it's considered by analysts the leading sort of a platform that does this. Other vendors are also following up this kind of a shift in the paradigm, but this is the first system that actually implemented and is available to you. So effectively what it does is that it marries these two big worlds, let's say, which typically we consider the big data world as something that requires to have immense storage area that will gather a lot of information that is not necessarily very valuable, let's say, to the reporting and the business line, but it's very valuable for the data scientists and other parts of the company. that it still needs to maintain, let's say, high availability, but it doesn't necessarily need to have a very strict kind of a security guidelines, like just-in-time masking and other parts, which, on the other hand, the data warehouse really needs. The relation on the repository that we typically call all these years a data warehouse will require sophisticated security sort of a setup on top. It will require the capability to have a very clear metrics inside there that will be cleaned up and combined together inside data marts that will then serve, let's say, to the business, and then they can, in a self-service kind of a BI manner, they can take over and sort of use any way they see fit. So in that sense, we get, through Synapse, we get one essentially tool that can, one sort of a place where we can manage and work in these both in these worlds. Now that's sort of one of the key aspects. The other one, the other aspect that is very sort of important to keep in mind with Synapse is the fact that it brings forward a set of tools, and soon enough we will have more announcements around this in order to manage the model. One of the things that the most experienced, let's say, in analytics will tell you, people will tell you, is that it's very important to have a data model within your analytical system that it will be flexible enough in order to survive the changes. And this is very important. We've seen time and time again big projects, let's say, in analytical systems to being set up, to being you know, accommodating, let's say, with specific data models. And then when they move forward, when the users come in and say, yes, okay, this data model is very nice, but I have these 2 extra fields that I need to add, or this extra 5 fields, or this whole domain that we didn't have before, let's say, that like the social, that we need to add, let's say, inside your data model, and the data model is not able to cater for. Quite often, we also see different data models all over the company not being combined, let's say, together. And the true insight comes when you are able to combine all these data models into one. And this is where the common data model approach, let's say, from Microsoft comes into play, which is embedded inside Synapse. And the idea here is that Synapse will be able to provide, let's say, one data model in order to encompass all these different kind of data models that we see in different domains. And the big benefit, let's say, from having that is that applications that typically need to cater for various different data models in order to be able to process the information and provide, let's say, the output to their users, usually have to be able to adapt, let's say, to different sort of repositories. Whereas within this approach, within Synapse, with a common data model, we will be able to accommodate, let's say, all this information, all this data, and we'll be able to provide one sort of way to connect and get value out of this information. Now, having said all that, as you can probably guess by now, that there are various sets of functionalities that Synapse enables. There is one that has to do with storing of information, the querying of information. You can have provisioned storage, or you can have serverless models that you can query, let's say, with serverless compute. You can have different kind of engines like the relational engine or the Spark engine in order to query this kind of information. Integration like the Synapse pipelines, the Studio, which is one common way that you can develop notebooks or coding pipelines inside there. And then, of course, the what I was talking earlier about the common data models, a way to easily extend, let's say, the data model that you have within Synapse in order to accommodate more and more kind of information that comes in from business or other kind of sources. Now, that's all nice when you see it in a deck. It's even nicer if you see it in action. So let's dive into it and sort of have a look about this. Now, the usual place to start all this is within Azure Portal. You typically log in, and then once it's loaded, you can go to Synapse. I already obviously set it up. One of the main benefits, let's say, with Synapse is the fact that you can set it up with a few clicks. Just click on the studio and then you log into the Synapse Analytics Studio. And this is the one central place where you can do all this setting up, coding, management, everything within one place. This is the central hub, let's say, of Synapse. Inside here, you have a bunch of options. The most standard one is to go inside there and see what kind of databases you have or what kind of other linked services you have. And here you get a feeling, let's say, of the good old SQL Management Studio that a lot of people used to work, let's say, on top in order to access the SQL Server data warehousing. And you can more or less do the same kind of, you have the same kind of functionality you had there. On the other hand, you also have these linked services. And here you can see that you have also access to the lake. So if I go back, let's say, to my Azure Portal, you see that I have storage accounts. And within there, I have a lake, a storage, which is effectively where I store immense petabytes kind of a scale of information, the big data kind of a concept that we were talking earlier. Okay, here I have for demo purposes just a few folders and just a file, but the idea is here that I can extend immensely here. Now, this kind of information, I can see it also through my studio, and most importantly, I can also query it. So if I click on it, right click and say new SQL script, with just a couple of clicks, I have a SQL statement that is running on top of the CSV file that I have in just a storage, let's say there. And if I click run, I can see the top 100. I can even sort of make it, give it a second. I remind everybody here, we are talking with a SAS disk, so a plain disk, it's not an SSD or something, very performant one. Nevertheless, I can query the data. I can see them inside there. I can also, for example, do some more fancy stuff. This is a churn data set. I'll have a true false whether the customer will leave, let's say, the company. So let's try something better. Let's do group by, shall we? So group by and see how many customers are truly churning and how many are not. So I can see, let's say, classic T-SQL over, let's say, just a file on a storage. I can accommodate. Now, keep in mind what we are using here. It's not the SQL pools. It's not something that I have set it up as a dedicated kind of capacity. No, this is serverless. This is something that I have always, with a click of a button, it just pops up, it allocates quickly, let's say, the resources, the computer resources necessary. And based on these computer resources, I can sort of directly make the query on top of the data I have in my lake. Obviously, it will not be as performant as the dedicated one. I have SAS disks, I don't have SSD disks. It's not going to be a huge compute kind of layer. It will be sort of a specific capabilities kind of compute. Nevertheless, it's very, very helpful when I'm doing this exploratory kind of queries, and I'm trying to figure out the data. I'm trying to figure out what I can do with the data. Later on, I can easily, let's say, transfer whatever I have, let's say, into the dedicated pool and keep the queries and data, keep using them, let's say, from them as a sort of a standardized kind of a way of doing the queries. Mind you, the same kind of capability I can also use that you've seen earlier, let's say, with this serverless component. I can also use if I want to query either information that might exist in an Oracle database or in a DB2 database or somewhere else. I can use what we call poly-based technology behind the scenes in order to query it. And in fact, I can combine the information. That's even more interesting. I can combine information that lives in the data lake or lives in a dedicated storage or in an Oracle storage within one sort of one query that is written in T-SQL, and I can query the data across those stores. always keep in mind the fact that if I query this data wherever they exist, perform the data virtualization, as we call it, the performance will not be optimum, right? This is something that you always need to have in mind. This is good for exploratory kind of reporting, but not for standardized kind of reporting that you need to serve the users as fast as you can. Another aspect I'd like to show, let's say, from the system is, if we go quickly, let's say, through the tabs, you will see that you'll be able to also develop notebooks, like, for example, Python scripts, let's say, on top of what I was talking about earlier, using the Spark engine, let's say, and its amazing parallelism, let's say, on top of the data I have perhaps in the lake, or perhaps do some machine learning on top of this as well. And also you can write the data flows and pipelines, let's say, of doing some sort of a data movement or transformation, let's say, of the data that you have or you ingest inside there. And then obviously I can stitch all this code into pipelines, and then later on I can monitor, let's say, this activity through the this monitoring UI that I have. Now, having said all that, another interesting aspect, let's say, that one needs to have in mind with Synapse is the performance and what you can get, let's say, out of this system, especially compared with the traditional ones. So let's connect to a data pool I have set up specifically for this. And I'm going to use the traditional SQL Management Studio for this, just to provide this old, nice look and feel, let's say, that we all, well, most of us have used in the past. And what I'm doing here is I'm connecting to demo DW in the cloud. You already see me do the connection, and let me copy paste quickly a query I have prepared a bit earlier. Now, inside here, obviously, I can see the tables. There, I've essentially used the sample data that I have, and I've loaded one specific table, the fact internet sales, as it's called. And you can see here, let me see if I can quickly run it. Did I run it? Sorry, I didn't. Let me press the button again. And then you can see that within a matter of just a second, I got a count over the fact internet sales, and what I get is about 1 billion of records. Now, if I want to actually run a query on top of this by combining, let's say, by combining various tables, so fact internet sales together with some other, which is the big table, let's say, with 1 billion of records, but together with some other dimensional tables, like the customer, etc., you'll see that the whole query will run with a group by, an order by, an account star, etc., will run within 6 seconds over 1 billion of records. Now, this is a very good performance, at least from anybody's standards that you've been using in analytics. The most interesting part is the fact that this kind of performance we got, if we take a look, let's say, in the, sorry, let me go directly to the pool that I've been using. Now, if you see the sort of a compute level that we're using is this DW500C. So this is the performance level that we're using. Obviously, I can scale to more or less. It's up to me, let's say, to define how much compute layer I need. But for this specific case, I use this one. So the performance that we've seen is based on this one. Let's see how much this will cost. So if I go to Azure.com and I go to pricing and pricing calculator, this is all public, by the way. You can play around, let's say, with this pricing calculator. So you can see that these 500 DW blocks that I've used typically costs this per month. However, if I commit to Microsoft that within the next 1 year or 3 years, I'll be close to Microsoft, the cost drops, and if I don't need geo redundant, the cost drops to 1 close to 1,500 thousands per month. And this is it. The storage, the SSD, the premium SSD disk is just 20 euros, and this is per month. Now, if you keep in mind what a comparable sort of a corresponding system will cost, let's say, in order to set up on premises, for example, a big MPP, massive parallel processing system that will be able to parallelize queries in order to give you this kind of performance, a few seconds per billions of records, then you understand that typically in the market, especially in on-premise, you'll get this kind of system with 1 million, 1.5 million to start with, not including maintenance and all the other sort of a labor that you need to sort of apply in order to set it up. So this is the price per performance is one of the key metrics that one needs to take always into account with these analytical systems, because this kind of performance you can always get, let's say, with other systems. But the issue there is how much you will pay in order to get this kind of performance. So this is something to have it always in mind, let's say, when one needs to compare, let's say, these analytical systems. Now, so as I mentioned, there are multiple things that we can sort of spend time over Synapse. I just highlighted a few of them for your information, for your to keep in mind. I didn't have enough time in order to sort of discuss the actual streaming layer and what we can do, let's say, on top of streaming layers, or what we can do with machine learning kind of components and how we integrate deeply, let's say, with Power BI. There are a bunch of other topics that we could be discussing over Synapse. And just to conclude, let's say, on this, and I'll be very happy if you like to sort of see that in a more detailed kind of workshop to follow up with you. Just keep in mind, this is, let's say, our most successful, let's say, analytical product service to date. It's been massive success with big and smaller kind of companies, and we have more actually within the next few weeks. You'll hear more announcements from Microsoft on top of Synapse, especially on the modeling part, but also other parts as well, that will make it even more compelling as an engine, let's say, to as an analytical sort of a tool to use going forward. So that's it from my side. Looking forward to hear your questions, let's say, in the chat. Thank you all.
Thanks very much, Dimitris. Very interesting approach as well. So thank you both, dear presenters, for keeping the time limits. So we managed to make it like with a very small delay, which is very good. So we have some time for Q&A. So please ask anything you want, and we'll try to answer online or offline, as we said in the beginning. I haven't seen any questions so far. So Cleopatra, is that correct?
Yes.
Okay. We'll just leave 1 or 2 minutes for any questions. In the meanwhile, I would like to remind that we've seen today, let's say, a solution package for data integration concerning both real-time and batch data processing. Okay, the combination of QDI and Azure Synapse together, which is a very successful, has been a very successful use case for numerous projects. So it has been tested that it actually works with minimum costs. So I see no questions, which means it's about time to close this event. Hope that you have found it useful. and some of questions have already been answered during the event, the presentations. At any case, WITSIDE remains at your disposal, along with Qlik and Microsoft, to answer any questions or go into deeper detail about how we can do it, how we can work successfully for a successful data integration project. Thank you very much. Have a great rest of the day. Bye.
Bye-bye.
Thank you all. Bye-bye.
Sorry. Excuse me, there is a question.
Oh, okay. From Nasos.
Yes.
Saved by the bell. Okay.
Yeah. Yes, Larry also already answered it. Yes, we do support the data tables. Yes.
Already used it in a project. So 100% yes.
Okay, good.
So contact us for any other questions. Okay, we remain at your disposal. Thank you very much once more. Have a great rest of the day. Bye.